elimination method. The elimination method is also called the addition method because we're going to add the equations together, and your book calls it the linear combination method. You are combining linear equations by addition to eliminate a variable. That's why it has 3 names, because you're doing all those things. Okay? I like elimination method way better than substitution. I think you will too, if you can. It's a lot shorter. So with elimination, we have to be able to add the equations together and one of them eliminate. Okay, so they need to add together and one of the variables has to equal 0. So I can first look at the equation and ask, is that going to happen right off the bat without doing anything? In this set of equations, yes. I have negative y and positive y. Those will cancel. So I don't have to do anything but add my 2 equations together. I'm going to combine them. 3x plus 3x is 6x. Negative y plus y is 0. So that zeroes out, and that equals 6. 6 plus 0. Divide by 6, and x equals 1. Now when I plug it back in, I can plug it back into either equation. Which one would you like to plug it into? The bottom one. So I like a positive y, so 3 times x, which is 1, plus y equals 0. I'm plugging it into 3x plus y equals 0. I'm going to get 3 plus y equals 0. Minus 3. And y equals negative 3. So my ordered pair is 1, negative 3. Okay. So there's 5 examples because it's like a progression. As the elimination gets harder, we take one extra step, right? And by the time we get to 4, that's the hardest, other than like it having fractions in it. Number 2 is 2x plus 4y equals negative 14, and 2x minus 3y equals 7. If I add these together just as they are, will anything eliminate? No, unfortunately, I have the 2's, but they're both positive, so when I add them, I get 4, right? So I need to multiply one of the equations by what? Multiply one of them by a negative, and that will make the negative 2x, so I can add them together. So let's multiply the top one by negative 1. Negative 2x minus 4y equals positive 14. Now I can add them together. My x's cancel. 2x minus 2x is 0. Make sure it's actually 0. Right? That's one of the big mistakes people make. They look at them, 2 positive 2's, and say, oh, they're the same. It's 0. But it's not until one of them's negative, right? Negative 3y minus 4y. Negative 7y. 7 plus 14, 21. Y equals negative 3. You can divide both sides by negative 7. Now I can plug it back in to any of these 3 equations. Which one do you want to plug it into? I'm going to do to the 2x minus 3y equals 7. I'm going to plug it in there. Y is negative 3, so 2x minus 3 times negative 3 equals 7. 2x minus plus 9, negative negative makes a positive, equals 7. Subtract 9. 2x equals negative 2. And x equals negative 1. So negative 1 comma negative 3 is my ordered pair. Questions? All right, number 3 then. Number 3 is 8x minus 5y equals 11. And 4x minus 3y equals 5. Okay, so if I add them together just like they are, will anything eliminate? No. So I can't just do that. It's not going to help me. I need there to be one variable so I can solve it. Do I have any coefficients that might be easier to get? Like they have a common factor? I mean, like in front of the variables. So yes, I'm going to do something to the bottom equation because, Justice? Both of them? The bottom one, yes. I want to multiply the bottom one by 2, negative 2. Why do I have to multiply by a negative? Yeah, they got to cancel, so one has to be opposite. Now, if I didn't see that right off the bat, could I use y? What's a multiple of 5 and 3? 15. So I can multiply both equations to try to get the y to have a 15. But it's easier if I just have to multiply 1, right? Less steps, less room for mistakes, right? So we get negative 8x plus 6y equals negative 10. Now, what I see a lot of is people trying to add this equation with the bottom equation with all this stuff in the middle. Okay, that's laziness, and that usually causes us to make a mistake. Take the time and rewrite the equation underneath. Okay, so we're going to rewrite this equation. 8x minus 5y equals 11, and that helps us not make some silly mistakes by adding the wrong number. Now we'll add it. My 8x, negative 8x and 8x is 0. 6y minus 5y is y. Y equals negative 10 plus 11 is 1. And then you could use any of the 3 equations. I like to start with the original equations because the numbers are smaller. So I'm going to go back to 4x minus 3 times y, which is 1, equals 5. 4x minus 3 equals 5. Add 3. 4x equals 8. And x equals 2. What's my ordered pair? 2, 1. Always x, y. Two x plus 3y equals negative 2. 9x minus 4y equals 26. Please change that from the worksheet. Okay, so if I add these together, nothing eliminates. I don't have any common factors for 2 and 9 or 3 and 4. They have common multiples, right? If I wanted to get rid of x, what's the common multiple for 2 and 9? 18. And what's the common multiple for 3 and 4? 12. So which one do you want to use, 12 or 18? Ooh, that was mixed. Okay, 18? All right. I don't know. Let's use it. Let's multiply the top equation by what so that I get 18x? 9. So I have 18x plus 27y equals negative 18. Now, since both the 2x and the 9x are positive, on this one I've got to multiply by a negative, otherwise they won't eliminate. So what am I going to multiply the second equation by? A negative 2. And I get 9 times negative 2 is negative 18x. Negative 2 times negative 4y is plus 8y. And 26 times negative 2 is negative 52. You get big numbers either way. There's a 26 in there. Yes.
Isn't it 27 or 26?
I said to change the problem on the paper to a 26. Otherwise, it doesn't work out nicely. So when I add these together, I get 18x minus 18x is 0. 27y plus 8y is 35y. And 18 plus 52, negative 70. And that's why we changed it to a 26, because this wouldn't have come to 73. Divide by 35, and y is negative 2. Plug it back in. I can plug it into any of the equations, any of these 4. But I'm going to plug it into the smallest one. 2x plus 3 times negative 2 equals negative 2. 2x minus 6 equals negative 2. Add 6. 2x equals 4. X equals 2. So my ordered pair? 2, negative 2. Okay, and the last one, which is super short, 4x minus 3y equals negative 6. Negative 4x plus 3y equals positive 6. What happens when I add these together? 0, 0 equals 0, which is true. So what does that mean about my solutions? Yes, infinitely many solutions. And Miss Whip wrote infinite many solution on your note. So that's a little abbreviation.